Hiya, you guys. So in this screencast, I'll demonstrate an advanced MongoDB aggregation framework query using Mongo Shell. So we're basically working with a custom-built dataset that I've uploaded into MongoDB Compass under the database called ResearchDB, and the collection is called Projects. So this dataset contains over 1,000 university research projects, and with fields like project value, project lead name, and university city. So plus arrays like resources. So before diving into aggregation, let's preview the document structure using the pretty function. And I've already run it, but let's try to run it again so we can see ourselves. So basically, you can see here, notice how each document includes embedded subdocuments and arrays like project lead here and resources here. So this is ideal for multi-layered aggregation because for any kind of aggregation really. And so let's start how we built this query. But the most important query function here is called the facet function, because basically facet function allows us to run multiple aggregation pipelines in parallel, so meaning we can compute several institutional KPIs in one go. And you can see here we try to build this up incrementally. So first we'll test each of the sub pipelines by its own, and then we combine them using the facet function. So now let's try that. Let's start. So we've already basically built this sub pipeline called the funding profile, because we want to basically what's important is basically we want to help compare institutions based on research value, and that's why we use the sum function, average function, max, and sum function. And the group here behaves like a group by in SQL. So let's run that really quick to see individually, and it's basically, you can see it's already calculated the average, total, and max project count of the university basically. And basically this is really good because we want to see how many projects that were already led by the university. It'd be really good for the knowledge of researchers. And another alternative is that basically push function can also be used to collect each project value into an array before summarizing, and it's a lot more memory heavy. That's why we don't really use them. And yeah, so it's ideal for founder reporting at performance analysis at institutional level, and that's why we created this certain sub pipeline. And let's move on to the next. Is basically we've created the publication stats sub pipeline, and we'll run that real quick. And why is this matter? Is that because basically this is to measures academic output, publication volume, and diversity of the lead authors. So we've used several functions here. We've used the add to set function. As you can see here, it basically captures only unique authors and avoid duplicate counting. And the project function also basically to shape the output to include only fields of interest, and basically think of it as a MongoDB's version of select if you want to compare it to SQL. And size function also is here, also basically to count the number of elements in an array, in this case unique researchers. Push function could also be used to include duplicates. Set union function also could be used to merge multiple arrays from different groups if you want to find an alternative to that. So it's very useful for researcher mapping, team formation, and identifying prolific institutions. So basically why we use add to set as the main function in the sub pipeline is because we don't want to double count authors. And yeah, so that's why we've used that for the main thing. Basically, it's the main focus of that particular sub pipeline. So let's move on to the next sub pipeline, which is the subject breadth. So we'll run that real quick. And you can see the number of disciplines, number of specialism in this pipeline. Basically, it's just the main reason why we created this is to basically capture how many unique academic disciplines and specialism are represented by each university. And we've used group function, basically again to group by university name, and you can see here, and at the set also we've also used that as a main function here, basically to create arrays of unique values for discipline and specialism. And another thing is we use project function and plus size function. So it's basically to reduce two clean numeric fields, which is ideal for dashboard bars or radar charts. And another thing is that people probably would ask, why don't we use count functions? Because we are dealing with arrays and we can't really run them basically, because we're dealing with we're dealing with arrays basically. And reduce function or map function could also be used to offer deeper transformation, but they're a bit more complex. And basically for subject breadth, is basically useful for curriculum partners, grant reviewers, or academic strategists assessing like subject coverage. That's why we've created that. And the last sub-pipeline that we did was the resource footprint. We run that real quick. And it's basically to reveal how widely and diversely each university uses resources like labs, HPCs, or whichever that was related to the research. And we've used functions such as unwind here. It flattens the resources array, similar to a function called unness in SQL, or a lateral join. And add to set has also been used to track unique resource type. And sum, of course, we want to total up all the resources instance across projects. And the project and size function here we use to output number of unique resources types and total usages. And another thing was why unwind functions, because you need to count or filter items within arrays all individually. So it's similar to SQL join flattening basically. Another alternative is that mapped function or reduce function for more advanced reshaping of the whole queries basically. And filter also could be added to isolate only a few resources types. Like for example, we just want to isolate PCs or printers, and filter can be used for that. And if you want to add on another function. So this is really useful for tech budget planners, infrastructure evaluation. So it's very useful for lab inventory dashboards. And finally, that's what we did basically. In the end, we used the facet function to combine all these sub-pipelines that we've created individually. And basically, you can see here that's the structure of the query. And afterwards, you can see this is all after we combine all of them. And when we run all of them, you can see individually it views each sub-pipelines separately. But then it's also all together, so it runs everything at once. And basically we've used several powerful MongoDB tools like Facet, Group, Project, Add to Set, Unwind Size, all tested in Mongosh using the ResearchDB project dataset. So this query is ideal for researchers to create dashboards, strategic planning, and research policy reporting. So that's all for the query that I've created here. Yeah, so thank you.